July 17th, 1943. A coastal road near Gela, Sicily. The captured American vehicle sat abandoned after its crew had withdrawn during the chaotic first week of Operation Husky. Oberleutnant Werner Stein had seen countless Allied vehicles during the North African campaign and Sicily landings, but this one struck him as particularly absurd. It looked like a truck that had melted, its body warped and bulbous, sitting unnaturally high on oversized tires. Standard procedure dictated destroying abandoned enemy equipment, but Stein had developed a mechanic's curiosity during 2 years of desert warfare. This vehicle was different. It had arrived on the beaches during the invasion not from a landing craft, but through the surf itself, driving through chest-deep water as if it were a dirt road. He had watched from defensive positions as dozens of these ungainly machines churned through the waves, climbed the beaches without hesitation, and continued inland carrying supplies. No unloading, no waiting for shallow water, just continuous movement from ship to shore to depot. "Get our mechanics," he ordered. "I want to understand how this thing works." What Stein and his team discovered over the next several hours would challenge fundamental assumptions about engineering philosophy. The revelation came not as dramatic realization, but as mounting evidence of an approach to vehicle design that seemed impossible yet clearly functioned. The Americans called it a DUKW. The soldiers pronounced it DUK. The official designation followed General Motors nomenclature: D for the year 1942, U for utility amphibious, K for all-wheel drive, W for dual rear axles. Nothing about those letters suggested the vehicle's most revolutionary characteristic. This truck could swim. The first mechanic circled the DUKW slowly, notepad ready, length approximately 9.5 meters, width about 2.5 meters, height nearly 3 meters with the canvas top erected. The proportions seemed wrong. Too tall, too wide, too clumsy for a military vehicle designed to operate in combat zones. But the details told a different story. The body was a watertight hull, welded steel construction that sat where a normal truck's cargo bed would be, no separate chassis. The entire vehicle was built as a floating container. The hull rose high above the wheels, creating enormous ground clearance. The Americans had designed this vehicle, expecting it to traverse obstacles that would stop conventional trucks. A second mechanic opened the engine compartment. The familiar GMC inline 6-cylinder motor sat there, the same 270 cubic inch engine found in the CCKW trucks Germany had captured in quantity. Nothing exotic, nothing revolutionary. The Americans had taken a proven engine from their standard truck and adapted it for amphibious use. The simplicity was striking. Stein approached as the mechanics continued their inspection. "What have you found?" Senior mechanic gestured to the rear of the vehicle. "There is a propeller, Herr Oberleutnant, a single 3-blade unit mounted beneath the rear deck. When lowered into the water, it engages directly with the engine's crankshaft through a power takeoff system." "Show me." The mechanic demonstrated the mechanism. A lever in the cab lowered the propeller into position. Another lever engaged the drive. The entire system was mechanical, simple, requiring no electrical components that might fail when submerged. This is how it moves through water. The front wheels provide steering even when floating. The propeller provides forward motion. The watertight hull provides buoyancy. There is a bilge pump to remove water that enters during operation. Everything is straightforward engineering. "But does it work?" Stein asked. The mechanic paused, choosing his words carefully. "We observed these vehicles during the invasion. They operated continuously through surf that would have swamped any boat. They carried full loads. They transitioned from water to land without stopping. The Americans did not beach them carefully. They simply drove onto shore at whatever angle was convenient and continued moving." Stein had witnessed this himself. During the first 48 hours of the invasion, American forces had landed over 130,000 men and 17,000 vehicles across beaches that lacked port facilities. The DUKWs had been central to that achievement. They eliminated the need for specialized landing craft to carry supplies from ships to shore. Instead, the supplies were loaded aboard DUKWs while still on the transport ships. The DUKWs drove down ramps directly into the sea, operated as boats until reaching shallow water, then simply drove up the beach as trucks. The process that would normally require multiple vehicles, multiple transfers, and extensive labour had been reduced to a single vehicle, making a single trip. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. One detail caught the attention of every German mechanic who examined the DUKW. The vehicle included a system for adjusting tyre pressure from inside the cab. Air lines ran from a compressor to each wheel. The driver could reduce pressure for soft sand, then increase it again for hard roads, all without leaving his seat. This feature existed on no German military vehicle. The Schwimmwagen, Germany's primary amphibious car, required manual adjustment of tyre pressure. The operator had to stop, exit the vehicle, and use hand pumps to modify each tyre individually. The process took 15 to 20 minutes in ideal conditions, longer in combat situations. The Americans had solved this problem with characteristic directness. They had installed a centralized air system that allowed instant pressure adjustment. The driver moved a lever. The system inflated or deflated tyres automatically. The vehicle continued operating without interruption. A junior mechanic voiced what others were thinking. This vehicle is not sophisticated, but it is remarkably practical. Stein nodded. That observation would prove more significant than any of them realized. The DUKW represented a philosophy fundamentally different from German engineering tradition. German vehicles were designed to achieve optimal performance through sophisticated engineering. American vehicles were designed to achieve adequate performance through practical engineering. The difference seemed subtle. The implications were profound. By mid-1943, German engineers had become familiar with American automotive philosophy through examination of captured jeeps and trucks. The DUKW extended that education into new territory. This was not just a well-designed vehicle. This was a vehicle that solved a problem German engineers had considered extremely difficult through methods that seemed almost crude. Stein spent that evening writing a detailed technical assessment. The report documented the DUKW's specifications, described its operational capabilities, and included his observations about American design philosophy. The report made its way through Wehrmacht channels, eventually reaching technical intelligence staff who had been compiling assessments of Allied equipment. Similar reports were arriving from multiple fronts. German forces in Sicily had captured or observed hundreds of DUKWs during the invasion. Each report confirmed the same conclusions. The vehicle worked. It worked reliably. It worked in conditions that would challenge far more sophisticated designs. The mathematics were troubling. Germany produced approximately 15,584 Schwimmwagens during the entire war. The Type 166, manufactured by Volkswagen and Porsche, was the most mass-produced amphibious car in history. German engineers took pride in this achievement. The Schwimmwagen was elegant, efficient, and effective. Ferdinand Porsche himself had overseen its development. It represented German engineering at its finest. Then, intelligence reports revealed American DUKW production figures. Over 21,000 units manufactured between 1942 and 1945. The Americans had produced more amphibious vehicles in 3 years than Germany produced in 4, and the American vehicles were larger, more capable, and designed for heavier loads. The Schwimmwagen could carry 4 soldiers and light equipment. It weighed 910 kilograms empty. It was powered by a 25-horsepower air-cooled engine. Maximum speed on water was 10 kilometers per hour. The vehicle was excellent for reconnaissance, river crossings, and liaison work. German officers loved it. The DUKW could carry 25 soldiers or 2.3 metric tons of cargo. It weighed 6.5 tons loaded. It was powered by a 94-horsepower engine. Maximum speed on water was 10 kilometers per hour. The vehicle was designed for logistics, supply operations, and sustained heavy use. American supply officers treated it as expendable equipment. A supply officer who had worked in German automotive plants before the war examined one of the captured DUKWs. His assessment was direct. This vehicle represents American industrial thinking applied to amphibious warfare. They did not try to build the perfect amphibious vehicle. They built an adequate amphibious vehicle that could be manufactured in massive quantities. He pointed to specific design choices. The hull is welded steel, simple construction. The Germans would have used more sophisticated hull designs with better hydrodynamics. But sophisticated hulls require skilled welders and take longer to build. The Americans chose simple construction that any shipyard worker could execute. The propeller system is crude, a single fixed-pitch propeller driven directly from the engine. The Germans would have designed something more efficient with variable pitch or multiple propellers. But complex systems require maintenance and specialized parts. The Americans chose simplicity that works reliably with minimal servicing. The entire vehicle is overbuilt. The frame is heavier than necessary. The suspension is robust beyond requirements. Every component appears designed to survive abuse that would destroy more refined equipment. The Americans expect these vehicles to be operated by inexperienced crews, loaded beyond rated capacity, and driven in ways no engineer would approve. They built accordingly. This analysis reflected a pattern German intelligence had observed across all categories of American military equipment. The Americans were not building equipment to optimal specifications. They were building equipment to operational realities. The difference was not technical, it was philosophical. A German vehicle was designed to perform excellently when operated, according to specifications by trained personnel using proper maintenance procedures. An American vehicle was designed to perform adequately when operated by anyone under any conditions with minimal maintenance. The German approach produced superior individual vehicles. The American approach produced superior operational results. Stein attended a briefing where these observations were discussed. The briefing officer had compiled assessments from multiple sources. His presentation was clinical and devastating. The DUKW first saw combat in Sicily. We observed approximately 300 of these vehicles operating during the initial invasion. By the second day of operations, the Americans were using them to ferry supplies directly from ships to forward depots. They eliminated the need for port facilities entirely. We captured Syracuse and Augusta as planned, but the Americans did not require these ports. They continued landing supplies across open beaches using DUKWs. The briefing continued with operational details. In the first 3 days of the Sicilian invasion, the Americans landed 150,000 troops, 7,000 vehicles, and 300 tanks. The majority of supplies came ashore via DUKW. Traditional logistics would have required weeks to establish supply chains sufficient to support this force. The Americans accomplished it in 72 hours. One officer asked the question others were considering: how many of these vehicles do the Americans possess? The intelligence officer consulted his notes. Production began in early 1942. Initial production rates were approximately 500 units monthly. By mid-1943, production exceeded 1,000 units monthly. Projected total production through 1945 is estimated at 20,000 to 25,000 vehicles. The room fell silent. 20,000 amphibious vehicles. Germany's entire Schwimmwagen production was less than 16,000 units. The Americans were building more amphibious vehicles every month than Germany could build in a year. But the numbers told only part of the story. The DUKW's significance lay not in quantity alone, but in what it revealed about American logistics philosophy. The vehicle eliminated the distinction between ship and shore operations. Supplies loaded aboard transport ships could travel directly to inland depots without transfer. The entire supply chain was simplified. Fewer transfers meant fewer opportunities for delays, losses, or confusion. A logistics officer who had studied American supply operations provided additional context. The Americans designed their entire amphibious warfare system around the DUKW. They do not plan to capture ports quickly. They plan to operate without ports for extended periods. Their naval forces include specialized ships designed to load and unload DUKWs efficiently. Their supply chains account for DUKW capacity. Their beach organization includes DUKW maintenance facilities. The vehicle is not simply equipment, it is the foundation of their amphibious logistics system. This represented another example of American integration. The Jeep was designed with standardized parts that fit multiple vehicle types. The GMC truck was designed with components interchangeable across manufacturers. The DUKW was designed as part of a system where every element reinforced the others. The Americans were not building individual pieces of equipment. They were building integrated systems. German military tradition emphasized tactical excellence and sophisticated equipment. The Wehrmacht had produced masterpieces. The Tiger tank was a masterpiece. The Panther tank was a masterpiece. The Schwimmwagen was a masterpiece. Each vehicle represented the pinnacle of engineering achievement in its category. But the Americans had demonstrated that integrated systems of adequate equipment defeated collections of individual masterpieces. A DUKW was not superior to a Schwimmwagen in any technical specification. But 20,000 DUKWs, operating as part of an integrated amphibious logistics system, achieved results that 15,000 Schwimmwagens operating as independent units could never match. Stein wrote in his final assessment, "The DUKW represents American industrial philosophy applied to amphibious warfare. They have created not just a vehicle but a system. The system works because every component was designed to function together. The vehicles are simple enough for mass production. The procedures are straightforward enough for rapid training. The logistics are robust enough for sustained operations. The entire approach assumes that quantity, simplicity, and integration matter more than individual excellence. This lesson, painful in its clarity, would be repeated across every theatre of war where German and American forces met. The Germans would win tactical engagements. The Americans would win operational campaigns. The difference was not courage or skill. It was industrial capacity organized around practical philosophy. By August 1943, Sicily had fallen. German and Italian forces evacuated over 100,000 troops across the Strait of Messina, but they left the island in Allied hands. The invasion had been an unqualified success for the Americans and British, and central to that success had been a vehicle that looked absurd, operated simply, and worked reliably under conditions that would challenge far more sophisticated equipment. The Technical Intelligence Office in Berlin received Stein's report along with dozens of others from Sicily. A team of engineers was assigned to compile a comprehensive assessment of the DUKW based on all available information. The assignment went to Hauptmann Friedrich Weber, an engineer who had worked for Opel before the war and understood both German and American automotive manufacturing. Weber began with the basic question that troubled every German engineer who examined American equipment. How did they achieve this level of production so quickly? The development timeline was remarkable. In March 1942, Major General Jacob Devers, chief of the U.S. Army's Armored Force, had written to Vannevar Bush, director of the Office of Scientific Research and Development, asking whether the OSRD could develop a way to move supplies from ship to shore without requiring port facilities. Bush, former vice president of MIT, had assembled a team that included some of America's most innovative engineers. The team included Rod Stevens, Jr., a yacht designer from Sparkman and Stevens who had won the transatlantic race in 1935. His firm had designed some of the most successful racing yachts in history. Dennis Puliston, a British deep-water sailor who understood marine engineering. Palmer Putnam, an MIT-trained engineer with experience in geology and volcanic research, and representatives from General Motors, which already manufactured the CCKW 2.5-ton truck. This combination of yacht designers, military engineers, and automotive manufacturers produced results in 42 days. 42 days from initial concept to working prototype. The Germans had taken longer to approve the paperwork for new vehicle development than the Americans had taken to design and build the DUKW. The prototype was based on the GMC CCKW truck chassis. The Americans had taken a proven vehicle, added a watertight hull, installed a propeller system, and tested the result. The approach was straightforward, practical, and astonishingly fast. But the prototype faced skepticism from US Army leadership. Senior officers could not envision how an amphibious truck would fit into existing tactical doctrine. The vehicle seemed like a solution searching for a problem. Production contracts were delayed. The project faced possible cancellation. Then came the morning of December 2nd, 1942. A storm, with winds exceeding 60 knots, hit Provincetown, Massachusetts. The U.S. Coast Guard patrol boat Rose, a small yawl on submarine watch, was caught in the storm and driven onto a sandbar near Highland Light. The 7-man crew found themselves stranded as their vessel began breaking apart in the surf. Conventional rescue boats could not reach the Rose. The wind and waves were too severe. The Coast Guard station called the nearby hotel, where DUKW test crews were staying. Several experimental DUKWs were in Provincetown for demonstration trials scheduled for later that week. Around 1 o'clock in the morning, Rod Stevens, Palmer Putnam, and Roger Warner Jr. responded with 2 DUKWs. Accompanying them was Coast Guard Commander Allison and, fortuitously, maritime photographer Stanley Rosenfeld. They drove to the beach near the stranded yawl. The decision was made to attempt rescue with 1 DUKW. Stevens, Putnam, Commander Allison, and Chief Silver crewed the vehicle. They reduced tire pressure to 8 pounds for soft sand, drove down the beach, entered the surf, and motored through 10-foot waves toward the Rose. The DUKW handled conditions that would have been dangerous for purpose-built rescue boats. The watertight hull kept the vehicle afloat. The powerful bilge pumps cleared water that washed over the deck. The 6-wheel drive provided stability. The vehicle maneuvered alongside the foundering Rose, took aboard all 7 Coast Guardsmen, and returned safely to shore. Rosenfeld photographed the entire rescue. He immediately returned to his New York studio, developed the prints, took a train to Washington, and delivered the photographs to high-ranking Army officials. The officials showed them to the Secretary of the Navy. The Secretary showed them to President Roosevelt. 4 days later, scheduled demonstrations proceeded off Provincetown. In 10-foot waves, DUKWs unloaded cargo from Liberty ships, carried howitzers through surf, and crossed sand dunes. Army. Observers were enthusiastic. Senior brass, witnessing the vehicle's capabilities firsthand, approved production contracts immediately. Weber studied this timeline carefully. The Americans had gone from concept to full production in less than a year. March 1942. Initial request. May 1942. Working prototype. December 1942. Dramatic rescue and approval. February 1943. First production units delivered. July 1943. Combat debut in Sicily. German vehicle development typically required 3 to 5 years from concept to production. The Schwimmwagen had entered development in 1940. Production models appeared in 1942. Even with Ferdinand Porsche's involvement and high-priority status, the vehicle took 2 years to reach mass production. The Americans had accomplished the same task in 1/3 the time, not because they were better engineers, because they approached the problem differently. They did not seek optimal solutions. They sought adequate solutions that could be implemented quickly. The DUKW was not the best possible amphibious vehicle. It was the best amphibious vehicle that could be designed in 6 weeks and produced in massive quantities using existing automotive manufacturing infrastructure. That distinction was everything. Weber compiled a section of his report on manufacturing methodology. The DUKW shared approximately 85% of its parts with the standard GMC CCKW truck. This commonality meant that factories already tooled for truck production could manufacture DUKWs with minimal retooling. Workers trained on truck assembly could build DUKWs with minimal additional training. Supply chains established for trucks could support DUKWs with minimal modification. The Americans had designed the vehicle for their manufacturing system, rather than designing a manufacturing system for the vehicle. This approach reduced development time, reduced production cost, and reduced logistical complexity. The result was a vehicle that could be manufactured by the thousands using existing industrial capacity. By mid-1943, two primary facilities were producing DUKWs: the Yellow Truck and Coach Manufacturing Company in Pontiac, Michigan, which was General Motors' truck division, and suppliers who manufactured hulls and specialized components. Production rates exceeded 1,000 units monthly. The Americans were completing more than 30 DUKWs every day. Weber compared this to Schwimmwagen production. Volkswagen's factory at Vorlesleben produced approximately 14,276 units between 1941 and 1944. Porsche's facility in Stuttgart produced 1,308 units. Total production averaged approximately 500 units monthly at peak capacity. The Americans were producing DUKWs twice as fast as Germany produced Schwimmwagens, and the American vehicle carried 5 times the payload. The disparity in total cargo carrying capacity was approximately 10 to 1. For every ton of supplies a fleet of Schwimmwagens could move, an equivalent American fleet of DUKWs could move 10 tons. But even these figures understated the operational advantage. The DUKW was designed for different tactical employment than the Schwimmwagen. The German vehicle was a reconnaissance car, used for scouting, command liaison, and crossing obstacles. The American vehicle was a logistics truck, used for supply transport, cargo handling, and sustained operations. The vehicles served different purposes. The more relevant comparison was between the DUKW and German logistics capabilities generally. Germany moved supplies using trucks, trains, and horse-drawn wagons. Amphibious supply transport was not a category that existed in Wehrmacht planning. River crossings required engineers to establish ferry operations or construct pontoon bridges. Supply depots were established only after secure lines of communication were established to ports or railheads. The Americans had created an entirely new logistics category, amphibious supply transport, that eliminated the distinction between naval and ground supply chains. This innovation changed how amphibious operations were planned and executed. It gave American forces capabilities that German forces could not counter because Germany had never conceived of the problem the DUKW solved. A Wehrmacht logistics officer provided Weber with operational context. In Sicily, we observed the Americans establishing supply depots inland within hours of landing. They did not wait to capture ports. They did not establish beachheads and then organize supply chains. They were moving supplies inland while combat was still occurring on the beaches. The DUKW allowed them to bypass the logistics bottleneck that would normally constrain amphibious operations. Weber included this observation in his report. The DUKW's significance is not its technical specifications, but its operational implications. The Americans can now conduct amphibious assaults without requiring immediate capture of port facilities. They can sustain operations across open beaches indefinitely. They have eliminated one of the primary advantages defenders possess in coastal warfare, the attacker's need for ports to maintain supply lines. This assessment proved prophetic. In June 1944, the Normandy invasion would demonstrate the DUKW's full potential. Over 2,000 DUKWs would participate in Operation Overlord. They would ferry supplies from ships to beaches across the English Channel in conditions that ranged from calm seas to heavy weather. Many DUKWs would be lost to rough seas and enemy fire, but the survivors would establish supply chains sufficient to support over 150,000 troops in the initial assault and millions more in subsequent months. The Rhine crossings in 1945 would provide another demonstration. American forces would use DUKWs to establish bridgeheads across Germany's major rivers without waiting for engineers to construct bridges. The vehicles would simply drive into the water, cross the rivers, and continue operations on the opposite bank. German defenders would watch in disbelief as American logistics crossed obstacles that should have required days of engineering work. But in late 1943, Weber was concerned with immediate tactical lessons rather than future operations. His report concluded with recommendations for German military leadership. First, Germany should attempt to develop comparable amphibious logistics capabilities. The report acknowledged this recommendation was impractical. German industrial capacity was fully committed to existing production. Developing new vehicles would require diverting resources from critical programs. The recommendation was included for completeness, but recognized as unfeasible. Second, German forces should prioritize destroying American DUKWs during amphibious operations. The vehicles represented a critical logistics capability. Disrupting DUKW operations would significantly impair American ability to sustain beachheads. This recommendation was tactically sound, but operationally difficult. The vehicles operated in areas protected by naval gunfire and air superiority. Third, German intelligence should continue monitoring American amphibious vehicle development. The DUKW represented one solution to amphibious logistics. The Americans were likely developing additional solutions. Understanding these developments would help German forces prepare appropriate countermeasures. The report made one additional observation that Weber included, despite knowing it would be unwelcome. The DUKW represents a pattern visible across all categories of American military equipment. The Americans are not trying to achieve technical superiority. They are trying to achieve operational superiority through industrial superiority. They build adequate equipment in overwhelming quantities. They design for mass production rather than optimal performance. They assume that training, logistics, and numbers will overcome any technical disadvantages. This approach has proven effective in every theater where American forces operate. The Jeep is not the best light vehicle, but there are more than 600,000 of them. The Sherman tank is not the best tank, but there are tens of thousands of them. The DUKW is not the best amphibious vehicle, but there are thousands of them operating as part of an integrated logistics system. Germany cannot match American industrial output. Our response must therefore focus on operational and tactical innovation that offsets their material superiority. But we must recognize that material superiority of this magnitude cannot be offset indefinitely. The Americans are applying industrial methods to warfare, with results that challenge fundamental assumptions about how wars are won. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Weber's report circulated through Wehrmacht intelligence channels in autumn 1943. It was read, discussed, and filed. The recommendations were noted but not implemented. Germany had neither the resources to develop comparable vehicles nor the industrial capacity to produce them in meaningful quantities. The report became one more piece of evidence documenting American material superiority, but individual Wehrmacht units took their own lessons from encounters with the DUKW. Units operating in coastal areas began treating American amphibious vehicles as high-priority targets. Artillery observers were instructed to call fire missions on DUKW concentrations. Aircraft were directed to attack DUKW operations when opportunity permitted. The vehicle's operational significance was recognized even when strategic response was impossible. German soldiers who observed DUKWs in operation developed respect for the vehicle's capabilities. A grenadier who fought in Italy wrote in his diary, "The Americans have a truck that swims. We watched them cross a river this morning without boats or bridges. They simply drove into the water and motored across. Our engineers would need hours to establish a crossing. The Americans did it in minutes. This is why they keep advancing despite our best efforts." This observation captured the essential truth about the DUKW and American equipment generally. German forces were not losing because they lacked courage or skill. They were losing because American industrial capacity produced solutions to problems so quickly that German forces could not adapt fast enough to counter them. The Schwimmwagen was an excellent vehicle. Ferdinand Porsche had designed it with typical German attention to engineering excellence. It was light, efficient, reliable, and effective in its intended role. German reconnaissance units valued it highly, but Germany had produced 15,584 Schwimmwagens during the entire war. That number represented the output of 2 factories over 4 years. The Americans produced over 21,000 DUKWs in 3 years, and they were designing even larger amphibious vehicles. The DUKW was just the beginning of American amphibious vehicle development. The bark, or barge amphibious resupply cargo, would follow. These enormous amphibious vehicles could carry 60 tons of cargo. The Americans were scaling up their amphibious logistics capabilities, even as Germany struggled to maintain existing production. By 1944, the mathematical reality was inescapable. For every Schwimmwagen Germany produced, America produced more than one DUKW, and each DUKW carried approximately 5 times as much cargo. The effective logistics capacity ratio was approximately 5-to-1 in America's favor. That ratio applied to amphibious vehicles alone. When all logistics vehicles were considered, the ratio increased to 7-to-1 or higher. Weber received one final assignment related to the DUKW before being reassigned to other duties. In December 1943, a relatively intact DUKW was captured near Ortona, Italy. The vehicle was transported to a Wehrmacht testing facility for detailed technical examination. Weber supervised the evaluation personally. The DUKW was driven on roads, tested cross-country, and operated in a reservoir. Every system was examined, measured, and documented. The hull was inspected for manufacturing quality. The engine was disassembled and analyzed. The propeller system was tested repeatedly. The tire inflation system was evaluated under various conditions. The conclusion was uncomfortable but unavoidable. The vehicle worked exactly as designed. It was not sophisticated. It was not elegant. But it was effective, reliable, and suitable for mass production by semi-skilled workers using standard automotive manufacturing equipment. Weber wrote his final assessment: "The DUKW is not a triumph of engineering. It is a triumph of practical design implemented through industrial capability." The Americans asked a simple question: how do we move supplies from ships to shore without ports? They answered that question with the most straightforward solution that could be manufactured in massive quantities. They did not seek perfection. They sought adequacy at scale. That approach has defeated our emphasis on engineering excellence through sheer accumulated mass. The war would continue for another year and a half after Weber completed his assessment. DUKWs would participate in every major Allied amphibious operation. They would cross the Rhine, the Po, the Seine. They would operate in the Pacific across countless island invasions. They would serve in Burma, crossing rivers and swamps that lacked any infrastructure. They would establish themselves as one of the war's most useful vehicles, despite their ungainly appearance and straightforward design. After the war ended, thousands of surplus DUKWs would be sold to civilian operators. They would become tourist attractions in waterfront cities. They would serve in rescue operations during floods and hurricanes. They would continue operating decades after the war, testament to simple design and robust construction. The Schwimmwagen, by contrast, would become a collector's item. Only about 163 examples survived the war in any condition. Most had been destroyed in combat or scrapped as Germany collapsed. The survivors were treasured by museums and private collectors who recognized the vehicle's engineering excellence and historical significance. Both vehicles achieved their designer's intentions. The Schwimmwagen was designed as an elegant solution to reconnaissance requirements, and it performed that role excellently. The DUKW was designed as a practical solution to amphibious logistics requirements, and it performed that role adequately at massive scale. But only one vehicle changed how amphibious warfare was conducted. Only one vehicle created new operational capabilities that altered strategic planning. Only one vehicle was produced in quantities sufficient to affect campaign outcomes. The story of these two vehicles illustrated the broader story of World War II in Europe. German engineering excellence confronted American industrial capacity. Individual German soldiers and equipment were often superior to American equivalents, but American industrial organization, mass production capabilities, and logistical systems produced overwhelming material advantage that tactical superiority could not overcome. A former Wehrmacht officer, interviewed by American military historians in 1953, summarized the lesson. We built the world's finest amphibious reconnaissance car. You built an adequate amphibious truck. But you built 21,000 of them, and you designed your entire amphibious warfare system around them. We could not match that. No nation could match that. You won not because your vehicle was better, but because your industrial system was better organized around practical solutions rather than optimal solutions. This understanding came too late to affect German military planning during the war. By the time Wehrmacht leadership fully appreciated the implications of American industrial philosophy, Germany had already lost the strategic initiative. The mathematical superiority of American production could not be overcome through tactical excellence alone. The DUKW remains one of World War II's most significant vehicles, precisely because it was not significant in traditional terms. It was not the best armed vehicle, not the best armored vehicle, not the fastest vehicle, not the most sophisticated vehicle, but it solved a critical problem through practical engineering and was manufactured in quantities sufficient to change how amphibious operations were conducted. That achievement represented American industrial philosophy at its most effective. Identify the problem, design an adequate solution, manufacture the solution in overwhelming quantities, integrate the solution into a comprehensive operational system, execute the system with logistical discipline. The approach seemed obvious in hindsight, but it represented a philosophical revolution in military equipment development. German engineering had focused on creating masterpieces. Each vehicle was designed to perform excellently within its category: the Tiger tank, the Panther tank, the Schwimmwagen. These were masterpieces of engineering that represented the pinnacle of their designers' capabilities. American engineering had focused on creating systems. Each vehicle was designed to function as part of integrated logistics and operational frameworks. The Jeep, the CCKW truck, the DUKW, these were components of systems designed to move supplies, transport troops, and enable sustained operations. The masterpiece approach produced vehicles that won admirers. The systems approach produced vehicles that won wars. By 1945, as Germany collapsed and Allied forces occupied the country, surviving Wehrmacht engineers had months to reflect on these lessons. Many would spend the post-war period helping to rebuild German industry. They would carry forward understanding of both German engineering precision and American production efficiency. The synthesis of these approaches would help create the German economic miracle of the 1950s and 60s. But in July 1943, standing beside a captured DUKW on a Sicilian road, Oberleutnant Werner Stein had only begun to understand what this vehicle represented. He saw an ungainly truck with a watertight hull. What he was actually seeing was the future of logistics, a future where adequate solutions manufactured at scale defeated optimal solutions manufactured in limited quantities. The DUKW taught that lesson to every German soldier who observed it in operation. Some learned quickly, others learned slowly, but by war's end, all had learned. The American way of war, embodied in vehicles like the DUKW, was not about building better equipment. It was about building adequate equipment in overwhelming abundance, integrating that equipment into comprehensive systems, and executing operations with industrial discipline. That lesson, learned at terrible cost, would shape military planning for the rest of the 20th century. The age of the engineering masterpiece had ended on the beaches of Sicily. The age of the industrial system had begun with an ungainly swimming truck that looked absurd but worked reliably, and existed in numbers that changed what was possible in warfare. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.